Now we want to apply some of these different concepts with trig equations. How do we simplify down for x or y? And when we do this, we want to find an exact answer or a rounded answer depending on how the instructions are given. But most times in trig, we're going to be finding an exact answer, which is why you can't just plug stuff into our calculator and say, hey, this is good enough. So here with our first expression, x times the tangent of 3 equals the tangent of 5. I can divide both sides by tangent of 3, which means my exact answer is going to be the tangent of 5 degrees over the tangent of 3 degrees. If I wanted a rounded answer, I would then plug that into my calculator. And since I said we're doing all these in degrees, we want to make sure that we're in degree mode. And you should round to 3 decimal places, which ends up being 1.669. The second example here, x times the sine of 37 plus x times the cosecant of 20 equals 10. This I've got the x's in front. And if the x's are in front of the trig functions, I can factor out without a problem. If they were inside here, inside the sines and cosecants, I couldn't do that. So this one is showing that I can pull the x out in front. And then to get x by itself, I would have to divide both sides by this quantity, sine of 37 plus the cosecant of 20. So here x would equal 10 over the sine of 37 plus the cosecant of 20. And if I plug that into my calculator, once again in degree mode, I get 2.836. The way you would enter cosecant of 20 into your calculator is you would convert this to 1 over the sine of 20, since we don't have a cosecant button on our calculator. The third example here, I'm going to bring out a separate sheet of paper because I'm running a little short on room right there. But part 3 says y plus 13 sine of 4 equals 5y minus 2 cosine of 10. With this one, I want to get all the y's on one side and everything else on the other. So let's bring this 5y to the left and this 13 sine of 4 to the right. So if I subtract 5y from both sides, I'll have a minus 4y. And if I subtract 13 sine of 4 to both sides, I'll have a minus 13 sine of 4 on the right. And then finally, we'll simplify by dividing both sides by negative 4. So 2 cosine of 10 plus 13 sine of 4 all over 4. And that is my simplified answer. I cannot simplify the 10 and the 4 inside of sine and cosine because those are inside the trig functions. And if I plug that into my calculator to get a rounded answer, that ends up being 0.719. The fourth example here, I would put a little star by because you're going to use this concept quite a bit. X plus the sine of 3 over x plus the sine of 4 is equal to the tangent of 5. How do I solve for x when I've got x's in two different quantities, specifically in a numerator and the denominator? So in this case, we need to first get rid of that denominator, and then we're going to move all the x's to one side, everything else to the other. So these guys right here are quantities. Cannot cancel x's, cannot simplify signs. So I'm going to get rid of that denominator by multiplying both sides by x plus sine 4. So then these guys will cancel out. I'm left with x plus sine 3 is equal to the tangent of 5, x plus sine of 4. If I move the sine of 3 over, I've got an x over here which I've got an issue with. So I need to now distribute this tangent in so I can get rid of my parentheses. So x plus sine of 3 equals x times the tangent of 5 plus tangent of 5 times the sine of 4. And I chose to write the x in front here because if I were to write it as tangent of 5 times x, it might look like the x is attached to the 5, and we want to avoid that. Now that I've got everything expanded out, I can move all my x's to one side, everything else to the other. So I'm going to subtract this x times tangent of 5 and bring it to the left, and the sine of 3 I'm going to subtract and bring it to the right. So x minus x tangent of 5 is equal to the tangent of 5 sine of 4 minus the sine of 3. And here's the big piece. On the left-hand side, I now have x minus x tangent of 5. A lot of people want to divide by tangent of 5 at this point. Can't do that yet. We first need to factor out an x. And now I've got 1 minus the tangent of 5. And then finally we can divide through by this 1 minus tangent of 5 quantity. So x equals the tangent of 5 sine of 4 minus the sine of 3 all over 1 minus the tangent of 5. Another way you could have solved this problem out and gotten the exact same result, but the answer looks different, would be if your terms were switched. In other words, if this quantity ended up being over on the left-hand side and your x plus sine of 3 was on the right, and you solved in a different order, you might have ended up with x equals the sine of 3 minus the sine of 4 tangent of 5 all over the tangent of 5 minus 1. You can see they're all the same pieces, just with different negative signs in there. Basically, we multiplied through by a negative 1. So all the negative quantities became positive, all the positive became negative. But these are two exact identical answers that you could have gotten. And the decimal equivalent for that would have been negative 0.051. The last example then, x times the cosine squared of 43 minus x sine squared of 15 is equal to 5.2. This one is just once again showing that we can pull out the x's in front. And then I can divide through by that quantity squared. And then the decimal equivalent to this would be 11.114. You can't put cosine squared of 43 into your calculator directly like that. The way you'd put this into your calculator is you could do the cosine of 43 times the cosine of 43, or you'd have to do the cosine of 43 quantity squared. There is no way to put the squared right in front of the cosine there.